Hello everyone. So in this video, we're going to briefly go through on our proposed solution in the engineering team project 1. So my name is Fidelis Juan Francis. I'm the team leader of this group, and we're going to propose our solution, which is the student productivity and occupancy tracker spot. We are from group 31 of engineering team project, and here are my teammates. So before we go through the proposed solution, we're going to go to the problem statement that we're going to address. So many university students are currently having issues when they are trying to find the available study areas, especially in the critical times in which tests and final examinations are around the corner. So most of them are actually having hard time in finding and wandering around the buildings to find the suitable space for them to study, especially in the IRC of University Technology Petronas. So during this critical time also, lots of students are studying as well. So this will end up with the overcrowding due to the critical type of the final examination and as well as the lack of real-time occupancy information provided by the staff. So as a result, this will disrupt the student productivity, in which results in unnecessary energy consumption in finding the unoccupied spaces. So we will go through the survey that we have made in order to further solidify our problem statement, in which one of the questions asked for the students was the average, how many times a week do they study in the library? So 50% of them answer they always study in the library 3 to 4 times per week, while others, they are actually studying 1 or 2 times or rarely for the other 50%, in which the 1 or 2 times are for the 30% and the other 20% is rarely per week. So this from this data, we can conclude that most of the students in UTP are actually frequently studying and attending the IRC for them to study. The next question is that how often do they struggle to find a seat in the library? 40% of the respondents in this survey answered they are always struggling to find the study spaces, while the other 60% they are actually frequently, sometimes or rarely, with 30%, 10% and 20% of respondents answer them respectively. So even though the majority of them are not always struggling to find, however, the 40% actually are affecting the overall management and also the efficiency of them to find the study spaces. So the last question that will further solidify our problem statement is that what is the most frustrating part of finding a seat in the study spaces? So most of them answer the seats are being saved by the people by putting their bags on the chairs. So this is actually the majority of the reasons and the most frustrating part of them in finding the seats. The seats are available, however, they are being reserved by the other students who put their bags on there and leave it for quite a lot of time. So this as a result will make them wandering around the buildings, finding available and free spaces for them to study, while others for out of the 100% actually finding a quiet zone for 30%, and also the 10% is finding a seat with a power outlet. So from this question, we can conclude that most of the students are actually struggling to find the seats because of the seats availability, especially in which the students are actually reserving their seats. So which is why we come up with the solution, our proposed solution, which is the student occupancy, student productivity and occupancy tracker, in which we call this as SPOT. It is actually an all-time device tracker proposed by our group, in which it continuously track the students' study space available and provide direct and simple data for the students. It is also efficient for everyone, which means not only the students are benefit from it, but also it can improve the productive data tracking for the IRC staff and also for the UTP facilities as well.
To maximize the impact of the student productivity and occupancy tracker, we propose the initial implementation at the IRC of University Technology Petronas. This location is ideal as it is a primary hub for student academic activity, where finding available seating is a frequent challenge. Beyond the library, the modular nature of Spot allows you to easily scale to lecture halls and discussion rooms, supporting the broader vision of a smart campus development. Now, looking at our design sketch, the system is designed to be as non-intrusive as possible. For the placement, the ultrasonic sensor is mounted on the backrest of the chair to detect occupancy, while the motherboard is tucked securely underneath the seat. For the interface, the data is transmitted instantly to a display screen located at the entrance or floor level. For the visual cues, we use a simple color-coded system. Red indicates a seat is taken and green shows it is free. This allows students to assess seat availability at a single glance without wandering through the aisles.
Next, I will explain about how it works. First, when a student sits on the chair, the ultrasonic sensor placed on the chair will detect the presence of a person. Then, the sensor will measure the distance between the sensor and the object in front of it. This measured distance then will be compared to a threshold value. If the measured distance is smaller than the threshold, it means someone is sitting on the chair. The system will label the seat as occupied. However, if the distance is greater than the threshold, it means no one is sitting there. The system will label the seat as empty. Finally, the result is sent to the display screen so other users can clearly see the seat status in real time.
To start our project, we evaluated 3 different types of sensors to determine which will be most effective for tracking chair occupancy. First, we look at the motion sensor. The cost is at 4 ringgit per unit. In terms of detection, it is limited to detecting moving people only. Its primary weakness is that it cannot detect stationary objects, meaning if a student sits still while reading, the sensor will report the seat as vacant. Next, we considered the weight sensor. This is the most expensive option at 7 ringgit. While it can detect both people and bags, it often misses items like a small backpack. It also has a significant weakness in installation complexity and the fact that it might not trigger at all for light objects left on the chair. Finally, we have the ultrasonic sensor. This is our most cost-effective option at only 3 ringgit. It is highly capable of detecting both bags and people by measuring the distance between the sensor and the object on the chair. While its weakness is that soft materials like thick jackets can absorb sound waves, we can overcome this through our software logic. Once we selected our sensor, we need to choose the brain of the system. We compared the ESP32 against the Arduino Uno. Looking at the connectivity, the ESP32 is superior because it has built-in Wi-Fi, Bluetooth and ESP now. The Arduino Uno would require us to buy and wire separate Wi-Fi adapters for every single chair, which is not scalable. Regarding power, the ESP32 features a deep sleep mode. This allows the sensors to run on batteries for months at a time, which is essential since we cannot run power cables to every chair in the library. The Arduino has high power consumption and typically requires a constant wall plug. Finally, we considered data speed. The ESP32 supports instantaneous peer-to-peer transmission. This ensures that as soon as a seat status changes, the display at the entrance updates immediately. The Arduino often suffers from latency or lag when multiple nodes are trying to send data simultaneously.
And next, in terms of feasibility, Spot is actually a very practical to implement. We are using widely available components like ESP32 and simple sensor modules, so it's easy to source and assemble. The system runs on a low 5V power supply, which makes it safe and energy efficient, and it can communicate in real time through Wi-Fi or Bluetooth. For cost, each chair unit is estimated between 28 ringgit to 82 ringgit depending on the sensor used. This makes it affordable, especially for a pilot setup in selected study areas. The system can be powered either by a 5V adapter or rechargeable battery, and since the design modular, maintenance and replacement are simple and straightforward. Most importantly, Spot is scalable. It can be expanded to lecture halls and discussion rooms, and in the future, the data collected can help monitor peak usage and support smart campus development. Overall, Spot is a practical and cost-effective solution that helps improve student productivity while making campus spaces more efficient.
So in conclusion, our product Spot is actually very practical, meaning it does not require any or provide any difficulty for the students when it is used. Not only that, it's very affordable. It does not require that much amount of money to be used and to be installed by the staff as well. However, it is also very scalable, meaning it can be used in the large, medium, or even the small scale, but providing a significant impact to the productivity of the students. Not only that, it is data driven, meaning our product is actually based on gathering the information and providing the simple yet impactful information and insights for the students when they are looking for the study spaces. And also, we hope that our product is actually a smart solution to improve the student productivity and campus efficiency. We hope that our product will not only impact the students, but also assisting other people as well, thus improving the sustainability and the community around the city and impacting the nation and the world. That's all from us. Thank you.